Now we'll discuss about the vector joining two points. See, first we'll consider 2 points, say P1 and P2. P1 vector coordinates we'll assume it as x1, y1, z1, and the coordinates of P2 we'll assume it as x2, y2, and z2. Now these are the 2 points. Now consider a point O and the 2 points P1 and P2. Now join this O to P1 and join the 2 points O and P2. Even at last join P1 and P2. So the direction is from P1 to P2. Now the vector which is joining the 2 points P1 and P2 is nothing but the vector P1 P2. So if we keep the arrow mark P1 P2 above that an arrow mark, the tail of the arrow mark should start from P1 and head of the arrow mark should be at P2, stating that the initial point is P1 and the final point is P2. Now, joining the points P1 and P2 with the origin will give a triangle-like structure. Now, we'll write the P1 point in the vector form. That is, OP1 vector is equals to x1 I cap plus y1 j cap plus z1 k cap. Similarly, the point P2 in the vectorial form will write it as x2 I cap plus y2 j cap plus z2 k cap. Now, we want to take the vector P1 P2. So, since P1 and P2 are the points, if we represent P1 and P2 in the vectorial form, we'll get it as a position vectors. So P1 P2 can be written as OP2 vector minus OP1 vector. So OP2 vector is x2 I cap plus y2 j cap plus z2 k cap minus x1 I cap plus y1 j cap plus z1 k cap. So if you subtract this OP1 from OP2, we'll get it as x2 minus x1 into I cap plus y2 minus y1 into j cap plus z2 minus z1 into k cap. Now we want to calculate the distance between the 2 points. One is known as P1 and P2. So magnitude of P1 P2 is equals to, it is nothing but the square of the coefficient of I plus the square of the coefficient of j plus the square of the coefficient of k. That is square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So by calculating the magnitude of P1 P2, then we'll get the distance between the 2 points P1 and P2.